Hi, hello everyone. This is your educator, your tutor, your friend, Sanjay Kumar Vishwakarma. I welcome you all to yet another session of We Learning. We Learning is a platform which focuses on providing right to quality education for all. So do watch this session. If you like it, do press the like button and share it with your other friends who are preparing for their boards and competition as well. Subscribe to our channel and do not forget to click on the bell icon so that you never miss any update from us. All right? And also visit our website www.vlearning.in. all right, v-learning.in. fine. There all these lecture notes you will be getting. Along with that you will be getting the live sessions also. Okay, go check it out. Fine. Now we were doing current electricity. This is lecture number 12. This is going to be the last lecture of this particular chapter, so I hope you all are happy. And I hope you have revised all the concepts here, because in this session again we are going to continue numerical problems only. Some more numericals will be seen. Okay. Let us start. Take out your notebooks and pens. We'll start. So here goes the first question. It says the total current supplied to the circuit by the battery is, you have to find the total current supplied to the circuit by the battery. So whenever you see a circuit like this, don't get confused with the shape. It is like a normal circuit only. Okay, if it is made a circle, that doesn't mean it's a different kind of circuit which you have never studied. All right. If you see here, this particular point and this particular point, both are at same potential. Correct? This is basically short circuit. I can join these 2 points. If I go here, 6 volt will be here, 0. 0 is here, right? 6 will be here, 6 will be here also, because there is no resistance in the middle where the drop is happening, correct? So since both are at same potential, this point and for this resistor there are 2 points, this and this. For this resistor there are 2 points, this and this. These 2 points are same. That means this resistor and this resistor are in parallel. Are yes or no? If these 2 resistors are in parallel, I can redraw this circuit as something like this, or if you want to curve, make the curve lines. From here there is 1.5 ohm also. From here there is another 6 ohm. Then there is another which is 2 ohm. So this point I have brought here, correct? This will be something like this. And then there is one more resistor below here, 3 ohm. See, the circuit is like this. Now these 2 I can solve. These 2 if I'll solve, this will be 1 by 6 plus 1 by 2. This will be 3 by 2. Just check. 1 upon r dash is equal to 1 by 6 plus 1 by 2. That is 3 by 6, 4 by 6. R dash is equal to, this will be 2 3s are, 2 2s are, 2 by 3. This will be 3 by 2 ohm, correct? So now this is also 3 by 2, 1.5. This is also 3 by 2. The equivalent here. So this circuit will be, a battery is connected like this. There is one resistance here, there is one more resistance here, this is 1.5, this is also 1.5, and one more resistance here. These 2 I can join, 1.5 and 1.5, and this will become 3. And this was already 3 ohm given. This is a 6 volt battery. 3 and 3 parallel means it will become 3 by 2. So now these 2 resistance, this will become 3 by 2. So again this will be a battery. One resistance, 3 by 2, 6 volt battery. How much is the current? Current supplied by the battery is equal to 6 by 3 by 2. That is equal to 4 ampere. See? 6 upon 1.5, 15 4s are 60. 6.0, 4 ampere. Right? That is the current. Easy? Very easy question. Only the shape of the circuit this time was different. Let's go further. This, try it on your own. Try to find the resistance here. The resistance between all the wires between any two dots is R. Okay. So now resistance in all the wires. Let me just write, this is resistance in all the wires between any two dots. So see, any two dots, this will be resistance R, 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 and R. Clear? So every small wire which you can see, the resistance is R. Now we have to find the equivalent resistance between A and B. Where is A? This is A. Where is B? This is B. Then here somewhere some battery will be connected. Alright. So now, let's forget about this. This is A, this is B. We have to find equivalent resistance. How do we do this? See, this is R. Always remember the points across which you have to see the resistance, okay? The equivalent resistance. Clear? Now see, we'll start from here, okay? Like this, if you see, it is looking a bit dirty. So what we'll do, we'll think that every wire is a resistance connected over here. Okay. Now if you see, these two are in series. These two are in series. Right? Then these two are in series. These two are in series. Now don't tell these two are in series. They are not in series. Because the point is A. Right? So these two, if I solve this wire, if I solve, this is R, this is R, how much this will become? R plus R, 2R. Let me make an equivalent circuit now here. So this is A. This will be like this only. Inside it will be like this only. A pentagon kind of shape. This is point B. Right? This 2 if I solve, this will be 2R. Right? This 2 if I solve, this will again be 2R. This 2 if I solve, it will again be 2R. Then this 2 if I solve, it will again be 2R. Correct? Do not solve these two. This is connected to A. These two are not in series. I hope you got this circuit the first time. Okay. Now this is R, this is R, this is R, this is R, 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 and R. So these 2R and R are parallel. So 2R and R are parallel means 1 upon R plus 1 upon 2R. This is 2 upon 2R. This is 3 upon 2R. 2R by 3. Here the equivalent will be 2R by 3. Here the equivalent will be 2R by 3. Here also the equivalent will be 2R by 3. Here also the equivalent will be 2R by 3. So let's make it. This is A point. Again a pentagon kind of shape I need. This is the B point. Now this time this is 2R by 3. This is 2R by 3. This is 2R by 3. And this is 2R by 3. This is R, this is R, this is R. Clear? Now see, these two are in series, these two are in series. Again, A is here, R, R, this is R. Here, these two in series means 2R by 3 plus 2R by 3 is 4R by 3. 4R by 3. These two are in series means 4R by 3. Then this B point is there here. Now if you see, all right, this R and this R, these two are separated from here. All the three are connected here. Acha, can you see a symmetry here? If I see like this, okay, let me make it proper so that you can see a symmetry here. Okay, 1 second. Just be here properly. A is like this, then this, then this. This is R, this is R, this is 4R by 3, this is 4R by 3, this is R. Can you see a symmetry here? Folding symmetry, if you remember. Across AB, I am seeing, across AB, can I fold this like this? Can I fold this circuit? See here. I can fold it. There is a folding symmetry. Do not forget the basic rules what I have explained, the basic tricks about the symmetry and all, okay? Maybe a very tough question, you solved it, you made it simple. Now it is looking like simple, but still at the end, you need to understand, you need to get that this is a folding symmetry. If you forgot here, then you will not get the answer and all your efforts have gone into vain, right? So now see, this is a folding symmetry. If I fold it like this, how the circuit will become? I told you when we fold it, then this and this will be parallel, this and this will be parallel, right? Or these resistances will become half. And this one, if you see, if I fold it, see this is A, this will be one resistance, this will be one resistance, this is B. This resistance will become half and it will not be connected anywhere. So this is like a half wire which is hanging, right? So this is senseless. We don't have to draw this one, this half. All right. Whenever there will be a half wire, that is senseless. Okay, because it is not connected anywhere. So now this will become R by 2 and this will become 2R by 3. Correct? Half. The resistances will become half. Now these two are in series. Since these two are in series, this will be R by 2 plus 2R by 3. A, B. R by 2 plus 2R by 3, that is 6. 2 3s are 3R plus 3 2s are 4R. 4 plus 3 7. 7 by 6R. That is the equivalent resistance between A and B. I hope you got this. Easy question. Just here there was something which you already studied, you just have to recall it. 7 by 6R, B is the answer. Done? Okay. Let's see the next. Again from here also, if you see, directly there is a symmetry. See? There is a folding symmetry. This resistance will become half. Okay, you can do directly also without solving that much. If at first only you see symmetry, see here, if at first only if I see there is a symmetry, if I fold it, all these resistances will become half. So this will be A, let's say is here. This will become R by 2. Then this will also become R by 2. Okay, let me make how it is. See here, this is A point, this R by 2, this R by 2, this R by 2, this R by 2, then this R by 2, this R by 2, and then this R by 2, and this is the B. Just check R by 2, R by 2. Okay, this R by 2, I can join it and make it R. These two, this is R by 2. This part, I can make it as R. These two also, I can make as R. R by 2 is R only, right? This is r by 2, this is r by 2. Just see, r by 2, r by 2, 2 by r, 2 by r. This will be r by 2, 2 by r, 1 by r. 2 by r, 1 by r, 3 by r by 3. R by 3, R by 3, 2r by 3 plus 2r by 3. See, finally we got the same. 3 to the 6, 2 to the 4, 7r by 6. So directly also you can do, your time could have been saved. I did not notice that here. I noticed it at the end. So many a times, here one more thing to learn. Many a times when we see the question, we just start solving the easy things. Right? And then later on we realize, okay, there was some shortcut also. So here this was a symmetry based question where at first only you could apply folding symmetry. Clear? Next, the charge flowing through a resistor R varies with time as Q is equal to 2t minus 8t square. So now charge is varying with time, it is time dependent. The total heat produced in the resistance is, how do we do this? First thing, if charge is there, we need to find current. What will be current? I is equal to dq by dt. dq by dt. I will differentiate this particular thing with respect to t. So this will become 2 minus 16t. Yes or no? This will be 2, this 8 to the 16, 16t, t power 2 minus 1, that is 1. So 2 minus 16t. Now see, they are telling the time given is, the time duration is 0 to 1 by 8. So what some students will do, I'll tell you, they will see, oh, I got the current. Then they will substitute this time is 1 by 8. They'll substitute this 1 by 8 there. So this will be 2 minus 16 into 1 by 8. That is 2. 2 minus 2 is 0. Current is 0. H is equal to I square RT. So I is 0. Heat is 0. 0 joule is not in the option. Since it is option based, then you can actually rectify your mistake. But if there were no options, people would have marked 0. Right? See, what we have to do is, we need to find the current which is dependent of T, right? But we need not substitute it here. We have to find the heat from the duration of 0 to 1 by 8 seconds, right? The formula for heat is I square, if current is not constant, if you remember, if current is not constant, it is I square R dt. Then H is equal to integral I square R dt. I told you about energy. Energy and heat are same thing, right? About energy, I told you, if you remember, P dt, integral. So this is I square R dt, integral. If the current is not constant, here the current is not constant, it is variable. Now you have got I, which is time dependent. So integral 2 minus 16, integration will be from 0 to 1 by 8. Here this will 0 and 1 by 8 will come. So this will be 2 minus 16t whole square R dt. R will go outside because it's a constant. This is from 0 to 1 by 8. Then this, if I open 0 to 1 by 8, this will be 4 plus 16 square, 256 t square minus 2 to the 4, 16 for the 64 t whole dt, correct? Integrate it. Now it is pure maths. H is equal to R integral 0 to 1 by 8. Okay, integration will do. This will be 4t (256) t cube by 3. (64) t square by 2. And the limit is from 0 to 1 by 8. From here, R, this will be 4 into 1 by 8 is 4 by 8 plus 256 1 by 8, 1 by 8, 8 8 is 64 into 8. Okay, or I'll write 8 into 8 into 8 into 3 minus 64 into 64 by 2, correct? 64 will come in the denominator. 64 divide by 64 into 2 minus 0 minus 0. Since t is in everywhere, so every term will become 0. That's why I've written minus 0. So this will be r into 64, 64 is cancelled. Now here 8, 8 3s are 24, 8 2s are 16, 8 4s are 32. Here half will come. Here also half will come, right? Here also minus half is there, correct? So this half and this minus half will be cancelled. We will be left with half, that is r by 2. No, we will be left with this one. This half and this half. This is basically half plus 1 by 6 minus 1 by 2, correct? That is equal to half and half are cancelled, r by 6 joules. If r is in ohm. Clear? I hope you got the point. When the current is not constant, then how to do? This is our answer. All right. Next. The variation of current and voltage is as shown in the figure A. So this is voltage versus I graph. The variation of power P with current is best shown by which of the following graphs? So there are 4 graphs, P versus I. For this variation, V versus I have to make a P versus I graph. How to do? In these 4, any one is correct. Guess your option. Write in your notebook. Not guess. Find your option. Write in your notebook. I'll find the answer. Then just match. Alright. See here, it is almost, V is directly proportional to I. Till here it's a straight line. At the end it is curved a bit, right? So almost it is V is proportional to I. V is proportional to I. P versus I, if I am making, P versus I means I square R in versus I. What does P versus I mean? Now R, if you see this, since V is directly proportional to I, since V is proportional to I, R, or you can say this, it's the slope, if you see, R will be constant, correct? So R is constant for maximum time, if you see. I mean, for this much current, if I take for some part of current, R is constant till here, till this value of current and voltage, right? Since R is constant, this R is constant. Basically, this graph is between I and I square. This is just a way to think. This graph is between I and I square. Now, if you remember the graph between X and Y, where Y is equal to X square. So, if graph will be between X and X square, what kind of graph it comes? It comes something like this, right? If you remember the quadratic equation where the square term comes, the graph becomes like this. If you remember, correct? So here, or if you try to trace this graph, y is equal to x square, if you try to trace, it will come like this. So this is basically I square, the same, x square. So the graph will be somewhat like this. Correct? So now, which graph matches? This one, right? This will be our answer. I hope you got the way to understand this. Okay. Next. This particular question, if you see, it is very important. Okay. These kind of questions they come same as it is. There are not much variation in this. Okay. A lot of times people actually learn the answer of these questions. I will also tell you the trick at the end to learn them, but first we will learn to solve these questions. Okay, what are these? Each edge of the cube has resistance R. There will be a cube. Each edge means each side will be having resistance R. These all resistances are R. Okay, all the resistance. Find the equivalent resistance across. So across these 3 points are there. These 3 things. One, an edge, face diagonal, body diagonal. So either you have to find across an edge, or you have to find across face diagonal, or you have to find across body diagonal. So now what is edge? Let us understand first. Okay, any side is known as edge. Okay, this is an edge, this is an edge, this is an edge, this is an edge. All these are edge. Fine. So now cross edge means this will be one point A, this will be one point B. So across AB the battery is connected, or across AB I have to find the equivalent resistance. Clear? It can be any edge. Any edge. It can be A and this point also. It can be this edge also, this edge also, this, any edge. Okay. So this particular thing is edge. Second, phase diagonal. They can ask for phase diagonal also. So phase diagonal means this is a phase, correct? There are total 1, 2, 3, 4, 5, 6 phases, right? So now diagonal of any phase. So if I consider this as phase, this will be the diagonal, right? This is the diagonal. So across the diagonal means this will be one point A, this will be one point B. Across this the battery will be connected. I have to find the equivalent resistance across AB. This is phase diagonal. Clear? Since this is on phase, this is the diagonal of the phase. If I join AB, this will be phase diagonal. Now, third comes as body diagonal. What is body diagonal? A diagonal which passes through the center of the body. So if you see this particular point A, if you see this particular point B, if I join this AB, this imaginary line, I am joining AB. This line AB is actually passing through the center of this cube, center of the body of this cube. So this is known as body diagonal. Clear? So across this, if I connect the battery and if I tell you to find the equivalent resistance across AB, that means I'm telling you to find the equivalent resistance across body diagonal. Okay. So this I can write as, this is the body diagonal. If I take these two edges, let's say this is edge. If I take, let me just mark CD. If I take this front face and this as the diagonal, this will be the face diagonal. All right. Clear? So now let's learn. First we'll see edge. We have to find equivalent resistance across an edge. Any edge it can be. Let us take an edge. This edge we'll take. All right. All the resistances are RR. There are two methods of doing it. Okay. First method is potential method. Now this method, I've already told you how to do using this method, right? If you remember in combination of resistance part 2, first I discussed about potential method. We solved certain questions based on this, right? So you know how to do it. Now we'll see how we can apply it here. Another method of doing is using Kirchhoff's law. But now we should know where to apply Kirchhoff's law. Kirchhoff's law is something which can be applied in any question. Okay, if you are not getting anything how to do, what to do, just apply Kirchhoff's law. It can be applied anywhere. But in exam, you have to choose that method which consumes less time. Here, there are 3 different things across which you have to find, right? 3 different questions will be there. For all the 3, potential method will take equal time. Okay, that will take less time. But Kirchhoff's law, if you see, for body diagonal, Kirchhoff's law will take very less time. But for the other 2, it will take more time. Okay, still I'll show you Kirchhoff's law method also. First we'll learn potential method. Okay, let's see. Potential method, what do we do? First we'll see which all points are at same potential, are equipotential. So step 1, if you want, write down, find equipotential points. Okay, Let us find. So first let us mark all the points. Label your diagram. A, B, C, D, E, F, G, and this will be H. Okay. Now, how to find equipotential point? We'll go at every point, we'll stand there and we'll see that this point is this much distance from A and this much distance from B. Then we'll find another point which is having same distance from A and B as the previous point. For example, let's say I'm standing here. See, from here I have three roads. I can go here, I can go here, I can go here. So first I will go to, I cannot go to B because that is anyways a terminal. Okay. So these two are the ones. I went to F. I'm standing here. Now I'm just measuring the distance. Till A, I have to cover one road. Right? Till B, if I have to go, I have to cover two roads. So I need to find another point standing at which, I need to find another point. If I stand there, the distance till A should be same as this distance, and till B should be same as this distance. Getting the point? I'm standing at F. Till A, this I have to cover one path. Till B, I have to cover two paths. Now I have to find a point which is same as F. That means if I stand there, till A I have to cover only one path, and till B I have to cover two paths. So which will be that point? Let's find out. Can that point be E? No, because till A only I have to cover two roads to come. The distance from A to E is two roads away. So that cannot be the point. So it can be H, because H is the only one which is one distance from A, one road distance from A. So if I stand at H, I have to cover one road to come at A and two roads to come at B. For F, one road till A, two roads till B. For H also, one road till A and two road till B. So F and H are actually equipotential points. They are similar, they are symmetric points. For me, F and H, both the point doesn't make any difference. Both are similar points. Okay. So from here, what I can write is F and H are equipotential points. Equipotential points. Clear? Second, not much space is there, so I am writing equipotential. Now 2 points are over. We have to check for every point. Let's go at C. From here B, if I go at C, I am standing here. Now from C to B, one path, and from C to A, two roads, two paths. I have to find another point, similar point. So if I stand at G, see, this will come by practice also. You have to make this diagram in your rough notebook, and you have to go stand at every point and see whether these 2 points are equipotential, these 3 points are equipotential or not. Okay, it will take some practice. Now from G, if you see, till B there is one road, till A there are two roads. From C also, till B one road, till A two roads. From G also, till B one road, till A two roads. So C and G are equipotential. C and G are equipotential points. Clear? Any other point? Let's see. So A and B are anyways terminals. 2 points are done. C is done, G is done, F is done, H is done. Only 2 points are left, that is E and D. See, E, if I am standing here, till A, the shortest distance is 2 roads away, 2 roads. And till B, again, it is 3 roads. So I need to find another point which is 2 roads away from A and 3 roads away from B. So if I see D, it is 2 roads away from B, not A. But I wanted 3 roads from B. So E and D are not equipotential. These 2 points were left. I checked for both. They are not equipotential. Alright. So now since we got to know equipotential point, now we will make the equivalent circuit. What we have to do with these equipotential points, we have to join these equipotential points. Equipotential means both are at same potential. I can join these two. See, let's say this point is at potential V. So this point will also be at potential V. For this resistor, one point is at A, this side is at point A, this at V. For this resistor, this is at point A and this side is point V. So basically voltage drop across this and across this is same. That means these two resistors are parallel. So what I'm trying to explain you is I can join F and H together because they are equipotential points. So now joining F and H together, F comma H, what will happen? See, F and H, if I join, this and this will come in parallel. This means from point A, one resistor is there which is connected to F. So from A, I have connected one resistor to F. From A only, I have connected one resistor to H. Okay. The same will happen with point E also. See, EF and EH. E is connected to F also. E is connected to H also. So basically, if you see, these two will become parallel, right? If I join these two. If you can visualize, it can be very good. Then E and D are connected just like this. E and D. Now see points C and G. I'm joining these two, right? If I join these two, this resistor which is connected across BG and which is connected across BC will become parallel. So if I mark this point as B, this resistor BC and this resistor BG, see B to C, B to G, parallel. And A and B are connected like this. Now, these two will also become parallel, DG and DC, see. So DG and DC, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are total 12 resistors in a cube. Total 12 edges, 12 sides are there. 2 resistors are left. Which are those two? Okay, if you see this resistor and this resistor are left. Now understand, if I am joining these 2 points and I am joining these 2 points, just see these 2 resistors. This one and this one. I am joining these 2 points and I am joining these 2 points. That means this and this resistor will be parallel. So F and G are connected and H and C are connected. See, they are coming parallel. This is our equivalent circuit diagram for this. Clear? Now all our resistance R. So these two are parallel, so this will become R by 2. This will also become R by 2. This will be R by 2. Here the equivalent will be R by 2. Here the equivalent will be R by 2. And these two will remain R and R. So our equivalent circuit will be R by 2, R by 2, R by 2, R by 2, R. And here one more R by 2. See, R by 2, 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 R, R. A, F, H, C, G, B, A, B, F, H, C, G, E, and D. Right? This is R by 2, 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 and this is R by 2, and this is R, and this is R. Did you get the same? Now see from here. This and this are in series. See, always remember our terminals. Our terminals are this, across which we have to find. So this are in series. R by 2 is R. R plus R is 2R. So from here the circuit what I am going to get is 2R and this R by 2, and here I am getting this is A, this is B. This is R by 2, this is R by 2, this is R by 2. These two I'll solve, 2R and R by 2. R will be 1 upon 2R, R by 2, 2 by R. So this will be 4 by 2r. This will be 4 plus 1, 5 by 2r. 2r by 5. Just do all these calculations on your own. Okay. So from here what I'll get is, this will be 1, 2r by 5. Here r by 2, r by 2, and this is 1. Okay, this is r actually. Don't forget, this is r across AB. Fine. This will be r, and these are our terminals A and B. R by 2 will be, these three are in series now. R by 2 is R, and 2r by 5 plus r. 7r by 5, correct? This will be 5r by 5, 7r by 5. So now the equivalent circuit from here will be seven r by 5 and this r. They both are in parallel. Solve this. How much will be the r equivalent? So this will be 5 by 7r, 1 by r, 7 by 7r, 12 by 7r, 7 by 12r, correct? 7r by 12. Just see, just calculate. This will be 7r by 12. This will be 7r by 12. Understood? Bouncer? No, right? It's an easy question. If you'll get it by practice, all right? So first, find the potential, equipotential point, make a equivalent circuit, and then solve it. Next, phase diagonal. Across phase diagonal, we can take any phase. I'll be taking this phase, the base one. Okay, it is up to you. You can take any phase. Let us name it. So if I'm taking this phase, I'll be taking these 2 points. Let's say this is A, this will be B. C, D, E, F, G, H. Alright. So first step is to find equipotential points. So let us go stand at every point and see the distance from the terminals. So first, there are 3 points. I can go here also, I can go here also, I can go here also. You can go anywhere and see, okay? Let us go to C first. I am standing here. From here, the distance till A is 1 rod and till B is 1 rod. I need to find another point which is having 1 rod distance from A and 1 rod distance from B. Okay, 1 rod distance from A means these 2 points are there. For equipotential with C, it has to have 1 rod with B also. So if I see this point, this is 1 rod with A, but with B, it has to go 3 rods to reach B. The distance, right? So this and this cannot be equipotential. Seeing D, 1 rod from A and 1 from B also. C is 1 from A, 1 from B. D is also 1 rod from A and 1 rod from B. So C and D are equipotential points. Find another equipotential point till then. See, I'll tell you one more trick. Once you find one equipotential pair, another equipotential point will be, just if I make a plane like this, see this face is there, CD is the diagonal. The same parallel face, this face will be there, EG will be the diagonal. So this diagonal will be these 2 points will be equipotential. Okay, you can see also. See, let's see G. G point, if you see, from A, I have to cover 2 rods distance to come to A. To come to B, I have to cover 2 rods distance. See, E to A, again there are 2 rods distance. To B, there are 2 rods distance. So E and G are similar points. E and G are similar points. So since they are similar points, E and G are equipotentials. Okay. But still, initially while practice questions, you have to go at every point and check whether they are equipotential or not. Here, C and D are equipotential, E and G are equipotential. See, in the previous question also, if you see, F and H were equipotential, right? If you see, this was the face. If I see the parallel face, C and G were the diagonal which is coming parallelly to it. C and G were equipotential. We found it also. In both the cases, it is similar only. Okay, so once you find one pair of equipotential, go to the opposite side, that similar pair will be the equipotential. Okay, all right. Now we got all the equipotential point. Now we have to make the equivalent circuit. How to make it? Let's see. C and D are equipotential, means I'll join this. If I join this, AD and AC will become parallel. Let me just join. Okay, CD I'm making here. A is here. Between A and C there is one resistance. Between A and D there is one resistance. Okay. Then BD and BC will also be parallel. See, if I join this. So if I make this B, let me make B here. All right. Now from A to C, there is a single resistance like this. No, AC I have already made. One second. This will be parallel, this will be parallel. Here this will be parallel, this will be parallel. Okay. Now let me make for this E and G. I am joining these 2 points. These 2 are now 1 point. So this and this HG, HE will be parallel. So if I make point H, now while making point H, don't make it up, make it in front of A. Why? Because H and A are connected, not H and B, right? See this also. So now H and E, there is one resistance between them. H and G, there is one resistance between them. See, these 2 will become parallel if I join this. Then F and G, F and E will also become parallel. F and G are having one resistance, F and E are having one resistance between. And F and B are connected directly. A and H are connected directly. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 more resistances are there. 2 more C and E. Okay, CE and DG. See here, if I am joining these 2 points, just see this resistance and see this resistance. These 2 points are joined, these 2 points are joined. That means these 2 resistances will become parallel, right? So EC is joined, see C point is here, EC is joined and DG is joined, right? Got it? Now see, all the resistances are done. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All are R. These 2 will be R by 2, R by 2, R by 2, R by 2. Where is B? This is B. Okay. R by 2, R by 2, R by 2, R by 2, R by 2. These 2 will be RR. Okay. A similar kind of circuit as the previous one, only the terminals are changed. So from here, let me make it R by 2, 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 R. Correct? These two are R. Rest all, see, they are parallel to another resistor R. Terminals, this is B, this is A. I hope you got the diagram till here. Now see, these two are in series. These two are in series. Always see the terminals also, okay? These two are in series. These two are in series. So this R plus R by 2, 3R by 2, R plus R by 2, 3R by 2. So here, this will be 3R by 2. This will be 3R by 2. This will be R by 2. This will be R by 2. There is one more in the middle, that is R by 2. This is B. This is A. See this particular circuit. Can you see a balanced Wheatstone bridge? Yes, right? Okay, let me make it simple for you. If I make this diagram like this, where A is here, B is here, this is 3R by 2, 3R by 2, this is 3R by 2, 3R by 2, R by 2, R by 2, this is R by 2. See, this AB was like this, I have done like this, R by 2 will come here, 3R by 2 here, 3R by 2 here, correct? And R by 2 here, R by 2 here. Now see, it is a balanced Wheatstone bridge, 3R by 2, and the ratio divided by R by 2 is 3, 3R by 2 divided by R by 2 is 3. So I can actually remove this middle wire. If I remove this middle wire, these two will come in series, so it will be, and the bottom two will come in series, so this will be 3R, this will be R, this is A point, this is B point. I'll write here balanced Wheatstone bridge. All right. Now see, 3R and R are parallel. So 1 upon 3R, 1 upon R. So 3 upon 3R, 4 upon 3R, 3R by 4. Just calculate. R equivalent will be 3R by 4. Got it? Clear? Okay. Can we move to the next one? All right. Body diagonal. Let's see the body diagonal now. Let's take this point as A. This point we'll take as B. This is the body diagonal, right? First point of this front face and this point of the back face. All the resistors are RR. First step is to find the equipotential points. Let us first label it C, D, E, F, G, H. From here, I'll start moving. If I move, I can go here also, I can go here also, I can go here also. Let me go one point. So first I am going to D, let's say I am standing here. To reach A, there is one path. To reach B, 2 roads I have to go. 2 roads I have to move. Okay, the distance. Another point I have to find with similar distance. So H, if I see one path from A and 2 from B, so they both are equipotential. If I see F, 1 from A and 2 from B, so that means all these 3 points are equipotential. D, H and F are equipotential. Clear? Now, A and B are terminals. The other points left are C, E and G. Let's see them also. From here, if let's say I'm standing at C, till A, the distance is of 2 paths. I have to move CH and HA. Till B, 1 road away, right? So 2 from A and 1 from B. Another point, E, 2 from A and 1 from B. Another, F, 2 from A I want, right? Okay. C, E, G, if you see, 2 from A and 1 from B. All these 3 points are 2 roads away from A and 1 road away from B. So C, E and G are equipotential points. Clear? C, E and G are equipotential points. All the points are covered. A and B are terminal. Then 3, 3, 6, total 8 points. Let's make an equivalent circuit. This will be a bit easy because it's completely symmetric. First, I'll make terminal A. I'll make terminal B. In the middle, there will be 2 points. One point will be D, H, F. Here it will be C, E and G. Between A, D, there is one resistance. Between A, H, there is one resistance. Between A, F, there is one resistance. Right? These 3, if I join, all these 3 will become parallel. Between D and C, there is one resistance. C point is here. So from each point there will be total 3 resistances, right? You have to count. From A, C, one this, one this, one this. Only 3 wires are coming from A. All the 3 have connected. From D also 3 wires are coming. One is connected to A, one to C, one to E. So A I have already done. To C I have already done. One to E also is connected. Fine. Now from H again 3 wires. One to A, that already is made. One to G, one to G, and another to C. C is also here only, right? Then F point. So 3 wires are there. One is connected to A, I have already connected. One is connected to E, one is connected to G. E and G both are here, so to both the resistors will be connected here only. Fine. Now see, D, H, F, all these 3 points are done. Now see, one is connected to D, one is connected to H, one is connected to B. Whatever is connected to D and H is already covered. The one which is connected to B, that has to be corrected here. 3 wires are done for C. For E, again 3 wires, 1, 2 and 3. One is connected to D, one is connected to F. D and F, we have already drawn that. Then to B, one is connected. Then 3 wires for E are over. G, one is connected to H, one is connected to F. G, one is connected to H, one is connected to F, that is over. Then G to B, one is connected from G to B. Now I hope you can solve this circuit. It is a very easy circuit from here. What will happen? These all are R. So this will be point A. This resistance will be R by 3. This resistance will be 1, 2, 3, 4, 5, 6. R by 6. This resistance will be R by 3. And this is terminal B. Just join all these, R by 3 plus R by 3 plus R by 6. 2R by 6, 2R by 6. 2, 3, 4, 5, 5R by 6. R equivalent will be 5R by 6. Clear? Understood? This was easy? Alright. So now we have seen one method in all the 3, that is potential method. Now let me show you Kirchhoff law, how to apply that. Okay. First I'll show you Kirchhoff's law here, because in here it will be the shortest. body diagonal using Kirchhoff law. Okay, so I have this cube. Just assume all the sides are having resistance R. I am not making, otherwise it will become dirty. Fine. Body diagonal means one point is here, one point is here. Now I'm going to use Kirchhoff's. For Kirchhoff, the first thing was, first step, distribute current. Okay. So first let's assume there is a battery which is connected like this. Fine. Across AB, a battery is connected of potential how much? V. So first thing was in Kirchhoff's law was to draw current from the battery. How to make this? Okay, let me make it simply. Fine. This is V, let's say. First, I will draw current from here. Let's say I have drawn current, the current is I. Now the current went here, I. It has three different paths. It has to distribute itself. But see here, this complete cube is symmetric. Why? Because from terminal A, if I have to reach terminal B, there are three paths. One path is this. One path is this. One path is this. All the three paths are equal. Here also three roads I have to take. This, this and this. Here also three. From here also if I go 1, 2, 3. From here also if I go 1, 2, 3. Current always takes the shortest path. Right? So for this point, if I am standing, I can take any road. I will not do any partiality, right? It's no road is favoring me. No road is smaller than 3 this distance, correct? So now current is here, the current will be distributed equally. Alright, current will not do partiality. Why should it give more current to this when it is having the same distance which this particular path is having? From here I can go like this also. Still the path is same, the length is same, right? See, 3 roads only. If I go here or here or here, see, if I go here, again I come here. There are again 2 different paths, that I understand. But again both are same. Either I go from here, 2 roads I have to travel. Either I go from here, 2 roads I have to travel. From here, if I go here and stand here, okay, again I have either this road or this road. But to reach B, if I take this road, again 2 I have to travel. If I take this, again 2 I have to travel. From here, if I go, I am standing here. If I have to reach B, I can travel this also, I can travel this also, but both are again same for me because here also 2 roads I have to travel, here also 2 roads I have to travel. If I go at any path, the current has to travel the same distance. So current will distribute equally. That is the main thing. So current distributing equally, I was there, it will be I by 3, I by 3 and I by 3. Clear? I'll make it neat. If I make neat, then black will also be erased. Okay, see, I by 3, I by 3, I by 3. After reaching here, as I told, I have 2 different paths. I can go like this also, I can go like this also. But both paths are same for me. So current will again divide equally. Here, this will be I by 6, this will be I by 6. Getting the point? Current I by 3 is there, standing here, thinking what to do. Both are equal paths, it will divide equally. Here also, current will be dividing equally. I can choose, this can choose this path also, this can choose this path also, right? I by 6, this also will be I by 6. For this I by 3, when it is standing here, again 2 paths, both are same. So this will divide equally, I by 6 and I by 6. Clear? So now, how much is coming here? I by 6. How much is coming here? I by 6. How much is coming from here? I by 6. I by 6, I by 6, I by 6 will be, wait, not I by 6. See here, at this particular point, this is I by 6. Okay, at this particular point when the current is there, okay, here one current is going I by 6 from here, one current is going I by 6 from here. So here it will be I by 3, I by 6 plus I by 3. I by 6 here, I by 6 here. They will join I by 3. Here also I by 6 is coming from here, I by 6 is coming from here. So this will be I by 3. Here also I by 6 is coming from here, I by 6 will come from here. So this will also become I by 3. I by 3, I by 3, I by 3 all joined together, this will become I and it will go to the battery. So our current distribution was correct. Once the current is distributed, the second thing was to select any one loop. Which loop I am going to select? Any loop you can select. Any loop. So I'll select the loop with the shortest route, okay, to make my calculation easy. So I am going to select this particular path. See, this. How many resistances are there? I hope you can see this, or should I make it from yellow color? This, and this. Can you see this path? Total 1, 2, 3 resistances are there. This is a closed loop, right? I have to just select one loop and solve for this loop. I'll get my equivalent resistance. You see how? For this loop, I am going to move in the same loop, in the same direction. Okay, in the direction of current I am moving. I'll be moving in the direction of current. Okay, so I am not writing here, otherwise again it will become dirty. I am moving in the direction of current. Now see, from here if I move in the direction of current, this will be plus V. This is negative, this is positive. I am moving towards positive, plus V. Then here one resistance will come in the direction of current, that is minus. Resistance is R, potential will be R into I by 3. Potential is IR, current is I by 3, resistance is R. One resistance here, R into I by 6 minus R into I by 6. One resistance here, minus R into I by 3. That is equal to, again from here I will come out, reach to the same battery, it will be equal to 0. From here V is equal to, this will be 2R by 6, 2R by 6, 2, 3, 4, 5, 5 IR by 6, correct? Now, circuit which will be, I want equivalent resistance, right? If I make a circuit with equivalent resistance, let's say this is R equivalent, a battery V, current how much? I. So if I want to write, see, battery V, current I, R equivalent, okay? If I want to write potential, this will be V is equal to I into R equivalent. If battery is having potential difference V, current drawn is I, then V is equal to I into R equivalent. Here also battery is V, current drawn is I. So I can write V is equal to I into R equivalent. So here I into R equivalent is equal to 5 IR by 6. Now see, I and I are cancelled. What we are left with is R equivalent is equal to 5R by 6. Clear? So from potential method also we got the same answer. From Kirchhoff's law also we got the same answer. Done. Now, other two also you can use Kirchhoff's law, but it will take a lot of time. Why? Because the first thing is you have to distribute current properly. Still, if you want to try, I'll show you. Let me start with edge. Phase I'll give you for homework, but let me show you edge one. Very less space is there. I'll try to do it. Okay. Edge. See. Across R equivalent across edge. R equivalent across edge using Kirchhoff's law. Fine. See here. If you are trying this stunt, make sure all the concepts are clear. Okay. Now, across edge means, now all these sides are having resistance R. Across edge means just 2 points. I'll take this as point A. I'll take this as point B. Fine. Now, this two I'll connect it with the battery. Current drawn will be I. Fine. Now, how to distribute this current? Finding symmetry is a bit difficult. To reach B, the main motive is to reach B. Here one path. From here again, see, if I go this way, 3 different roads. If I go this way again, 3 roads. What I can see is this path and this path are symmetrical. If I move from A to B, this path and this path, either I can take any path. For me it is same, but this is a very different path. So now current will be distributed as here there will be some current, let's say I1. Here there will be some current, but the current in these two will be same, because either I choose this path or I choose this path. For me, reaching B is the same distance. So here the current will be I2, here also it will be I2. Current will be same here, I2. Now see, this I2 will go and distribute in again to divide into. If I am standing here, I need to reach B. There are 2 paths. One this. Another one is this, the shortest one. Here also this. Now, from common sense, at least you can understand, if these are divided I2, this path is same, right? That means current in this and this will be same. Let's say here, in this, the current is I3. Okay, so here also it will be I3 in these two. Here, from here, how much current should come out? I was distributed in I1 plus 2I2. If you remember, I was I1 plus 2I2, total I. So here also I1 plus 2I2 should come from these 3 wires. That means from this wire anyways I1 is coming. See, this I1 I'll write close to it. From this wire anyways I1 is coming. From this if I2 and from this if I2 comes, total current will be I1 plus 2I2, correct? So if from here I2 is coming, from here I2 is coming, these two are having same. What does this mean? See here, I3 is going here. Let's say I4 is going here. One second. I2. Achha, these two currents are joining and becoming I2. So here, if I3 is distributed in I3 and I4, what does this mean? Here one should be I3, one should be I4, correct? Anyways, this is I3, so I4 is coming from here. How much current will be here? See, from here I3 is going. From here, current is I2 again. And I2 is, these two should join and become I2, right? That means if I3 is coming from here, this should be I4. Because I2 was distributed in I3 and I4. This is having I2 distributed in I4 and I3. This is having I2. So I4 and I3 should only join and become I2. So this will be I4. Correct? Here how much? See, again this is I2. So this is I3. So this will be I4. Very simple. So this I4 is going here, I4 is going here, this will be 2I4. Minimum variables in I4 in current, if you are choosing different currents, the minimum number of variables are I1, I2, I3, I4. And then you have to choose 4 different loops because 4 unknowns are there. Choose 4 loops, solve 4 loops, and make an equivalent circuit of it. R equivalent V, current what you have drawn is I, V is equal to I R equivalent. From here solving these 4, you will be getting 4 different equations. Solve them, finally you will get R equivalent. Okay, this current distribution is the main difficult task in Kirchhoff's law when applied here, that I have told you. Same distribution will be there. Okay, try it on your own. Clear? I hope you understood today's session. This was the last session. Okay, there is one short trick to remember all the 3. The short trick is, all the 3 we have discussed. Let's note the short trick. Here all the resistance are R. Okay, all the resistance are R. So if all the resistance are R, what you have to do is, first you have to write like this. Now first edge is there, then face is there, then body is there. Okay, first the smallest distance, then a bit bigger distance, then body diagonal is the longest distance, right? So that way you can remember. How to remember it? Start from here, 1, 2, 3, 4, 5, 6 and 7. These are the equivalent resistances. For edge, 7 by 12 R. For face, 3 by 4 R. For body, 5 by 6 R. This is the short trick to remember the equivalent resistance across edge, across face, across body in a cube having sides of resistance R. Alright. I hope you liked today's session. This was the last session of current electricity. In the next session, we are going to begin with the next chapter, with the new chapter. Just make sure all the concepts of this chapter are clear before moving to the next one. Okay? If you like today's session, do press the like button, share it with your other friends who are preparing for their boards and competition as well. Subscribe to our channel and do not forget to click on the bell icon so that you never miss any update from us. Okay? Visit our website www.v-learning.in. There all these notes, all these lectures you will be getting. Along with that you will be getting lecture notes also. Okay? We'll meet up in the next session. Till then, keep learning from